This is section 10.1, part A, sequences, series, and sigma notation. A sequence is an ordered list of numbers. Each number in the sequence is called a term. We have a finite sequence if there is a specific number of values or number of terms in the list, and we have an infinite sequence if it continues on for infinity. Now you will know the difference because on a finite sequence, it will just end in a number. On an infinite sequence, it will end in ... showing you that it's continuing forever. Each term in the sequence is a function of its position. Therefore, an infinite sequence is a function whose domain is a set of natural numbers and can be written as f of 1 equals a sub 1, f of 2 equals a sub 2, and that would continue on to f of n equals a sub n. If the domain of the functions is only the first n natural numbers, then the sequence is finite. Infinitely many sequences exist with the same first few terms. To sufficiently determine a unique sequence, a formula for the nth term or other information must be given. When defined explicitly, an explicit formula gives the nth term of an a sub n as the function of n. So we need to find the first 4 terms of the sequence. So they give us our sequence and we define the next 4 terms. Now we need to see what's happening. To get from 2 to 7, they can add 5. To get from 7 to 12, they add 5. And to get to 12 to 17, they are adding 5. So each time they're just adding 5. So if we continue this pattern, the next 4 terms will be 22, 27, 32, and 37. In the next set, they're adding 3 to get from 2 to 5. They're adding 5 to get from 5 to 10. Then they add 7 to get from 10 to 17. So if we continue the pattern, next time we should add 9, which will get us to 26. After that, we should add 11, which will get us to 37. Next, we'll add 13, which will give us 50. And then if we add 15, we will get to 65 for the next 4 terms. For the next one, they're going to give us an equation, and we have to find the first 4 terms in the sequence. So we need to find a sub 1, a sub 2, a sub 3, and a sub 4. Now that number tells you what you are plugging in for the n value. So we'll do 2 times 1, and then we're going to multiply negative 1 by that and raise it to the nth power, which in this case will be 1. So we have 2 times negative 1, which will give us negative 2. For the next one, we'll have 2 times 2, and then we're going to multiply that by negative 1 raised to the second power. 2 times 2 gives us 4, and negative 1 to the second power is going to give us a positive 1, so that'll give us 4. Now we have 2 times 3, and then we're going to multiply that by negative 1 raised to the third, or 6 times negative 1 raised to the third power. Since this is odd, it will remain negative. So we'll get negative 6. And this will give us 8 times a positive 1, because this is an even power, so it becomes positive. And this will give us 8. So the first 4 terms will be negative 2, 4, negative 6, and 8. Sequences can also be defined recursively. Recursive defined sequences give one or more of the first terms and then define the terms that follow using those previous terms. The formula defined by the nth term of a sequence is called a recursive formula. The Fibonacci sequence describes many patterns in nature. This sequence is often defined recursively. So this is a recursive formula because it's telling you you're going to take the a sub n minus 1, which means you're going to take the previous term, plug it in, and then solve. So they tell you the first term is a1 is equal to 1, and then for each of the subsequent terms, you're going to have to use the answer from the one before it. So we know a sub 1 is 1. A sub 2 tells us you're going to take the previous term, which is 1, and then we're going to add 2 times 2 minus 1 because our n value was 2. So this will be 1 plus 4 minus 1, which is going to give us 4. So to find A3, we're going to do 1 plus 2 times that previous term. Sorry, not 1. It's going to be our previous term is what comes first because it's a sub n minus 1. So the previous term plus 2 times the n value minus 1, or 4 plus 6 minus 1, which will give us 9. If we do a sub 4, we're going to take the previous term and we're going to add it to 2 times the n value minus 1, or 9 plus 8 minus 1 gives us 16. And it tells us to find the 5th term, so we are looking for a sub 5. So we take the previous term plus 2 times 5 minus 1, which will give us 16 plus 10 minus 1, which gives us 25. So the 5th term will be 25. Now previously we were talking about a Fibonacci sequence. This describes many patterns that happen in nature, and most Fibonacci sequences are often going to be defined recursively. So suppose that we plant, our plant starts to grow, and the stem has to grow for 2 months before it has strong enough support for branches. So after 1 month, we still just have a stem. After 2 months, we still just have a stem, but after that 2 months, it is now strong enough to start sprouting branches. At the end of the 2nd month, it sprouts a new branch and will continue to sprout another new branch after each month. So after 2 months, when we get to 3 months, we are now at 2 branches. We still have that original one that's going up, but it is now sprouted one out. So at 3 months, we are now at 2 branches. So at 1 month, we had 1 branch. At 2 months, we had 1 branch. But now at 3 months, we're up to 2 branches. Now each of those branches has to grow for 2 months before it can sprout another. So this main branch, as it goes up, when we get to 4, it's going to be strong enough to sprout another one. But this branch is only a month old, so it will not be strong enough. So when we get to the next one, again, we have this main one. It sprouted this one at 3 months. It sprouted this one at 4 months. So at 1 month, we had 1. At 2 months, we had 1. At 3, we were up to 2 branches. Now at 4 months, we are now up to 3 branches. Now this branch has been growing for 2 months. So at the next month, it will be strong enough to grow another branch. Our main one can grow another branch, but this one's only been growing for a month, so it's not going to grow anything else. So the next month, we're only going to be adding 2 more branches. So 1 month we had 1, 2 we had 1, 3 we had 2, 4 we had 3 branches, and now at 5 months we have 5 branches. Now again, this one has been growing, so it's been growing for more than 2 months. It's now grown 1 branch. It's going to be able to grow another one. This one's been growing the longest. It's going to be able to sprout a new one. This has only got a month in, so it will not be able to sprout another one. But this branch has now been growing for 2 months, so it's going to be strong enough to sprout another branch. So now at 6 months, we are now up to 8 branches. So if this pattern continues, how many branches will the plant have after 10 months? So let's turn this into a table. We have the number of months, let's make that an M for months, and we have the number of branches. So after 1 month, we have 1 branch. After 2 months, we have 1 branch. After 3 months, we were at 2. 4, we were at 3. 5 months, we were at 5 branches. 6 months, we were at 8 branches. We need to figure out 7, 8, and 9 to be able to figure out what will happen at month 10. Now, if you notice, 2 is equal to 1 plus 1, which is what we had the last 2 times. 3 is equal to 1 plus 2. So we take the two previous answers, we add them together, that's going to give us 3. If we take the two previous answers here, 2 plus 3 is going to give us the 5 that we have here. Then 3 plus 5 gives us 8. So to get to the next one, if we do 5 plus 8, that tells us on month 7 you should have 13. 8 plus 13, if we add those together, month 8 we should have 21 branches. 13 plus 21, if we add those together, you should have 34 branches. And if we do 21 plus 34, add the two previous together, we will end up with 55 branches at month 10. So the equation that they're using for this, to find our value, they're taking the value of 2 ahead of it and adding it to the value that is 1 ahead of it. So this is our recursive formula. It says take the two previous terms, add them together to get our new term. And if we do that, you are going to get the a sub 10 we found was 55.